Hello and welcome to yet another episode of QA Q&A. I am your host Shweta and today we have the winner of Magic with Selenium contest, Dimpy Adhikary. Dimpy is a highly experienced consultant at ThoughtWorks. With 18 plus years in the software testing industry, Dimpy is a leader in the quality engineering field and has a proven track record in developing and implementing successful testing strategies. Her expertise in building large-scale automation frameworks that balance coverage across both the front end and back end is unmatched. She has a hands-on approach to leadership and is a peer leader to top testing resources. Welcome to the show, Dimpy.
Hey, hi Shweta. Thanks a lot for giving me this opportunity. I'm really excited to talk to you on testing topic and looking forward to these discussions.
Yeah, and we are equally honored and excited to have you and talk us and share your insights about APIs especially. And with that, the first question would be, can you explain the term API or application programming interface to newbies in very simple terms?
Okay, I'll try my best. See, APIs are there in our life, right? So we cannot think about any product with APIs, at least at this point of time. So if you see, in very simple terms, right, API is nothing but, interaction between two parties. Now, just take an example like you and me, we both are talking. If we don't understand each other's language, right, so there's no point, like how much ever effort one person is putting, it will be in vain. It will not help anybody, right? The same way, right, in the software world, if we want to communicate between two parties, we need APIs. If it can be, a simple piece of code, right? So if you see in the object-oriented world, right? So objects communicate with each other using messages. But if you see in that particular class, or suppose you have two classes, they are communicating with each other. Both the classes are in same place or part of same code base. There's no problem. They can effectively communicate. But think about a situation where we have two pieces of software which are residing in two different places, maybe two different geographic locations, right? Where we need to do the communication via internet. So in that case, the example I told you before, we should have a common language, right? So in API world, we should have a common protocol, basically. So it can be, it can be HTTP protocol, right? Mostly we use HTTP protocols to communicate. So it can be, the communication can happen between two pieces of software or maybe two pieces of hardware also, or maybe combination of software and hardware, right? So whatever information I'm looking for from somebody, I'm looking for a piece of information on a particular book from you. So I will give you the details this is the book name, this is the author name, right? Or maybe this is the publication I'm looking for, and immediately you can give me the details. But for you, without those small piece of information, it will be difficult, right? So similarly, when we communicate in the API world, the consumers basically, right? So who is consuming the APIs? They provide some information to the server and say hey, give me this information, and server will process the request and send the information back, right? This is as simple as that.
Okay. I have never heard, a simpler definition that it's just a common language that two software pieces used to communicate with each other. I think I haven't heard a simpler way than that. So thank you. Moving on to the next question. Exploration is an important prerequisite to testing. So how does one explore a set of APIs on ground? And could you give our audience some working tips?
Sure, definitely. See, generally API doesn't exist in isolation, right? So we need some front end to explore the way we explore any application, right? So mostly there will be some GUI or there will be some front end, and we explore via that. But if we have a raw APIs, right? So there is no front end. So in that case, we can explore the APIs in a sandbox environment or with the documentation. Suppose you are a producer of any product, right? So you have created a set of APIs for some functionality. So first thing, like you will be creating obviously a documentation for that, so that the consumers can actually easily try out, right? So they can understand what that API are, what are the mandatory parameters needed to access that API, maybe what is the authentication techniques they have to use, and based on that they can start exploring the sandbox which as a product owner might have exposed publicly. So I may need to use some keys or to authenticate, but after that I'll be free to explore the APIs based on the need I have, right? That is one way. Another way is, suppose API is already integrated with some front end, right? So you want to explore that. So maybe you have provider has not provided any API documentation and they're just given an application to you, then just go and explore. So in that case, we have our own browser, what do you call it? Inspection, right? So you have developer tools inbuilt with all the browsers. So go to the developer tool, then try out the scenario you want to verify or you want to explore, and see what is happening in the background, like what kind of actually request is going to the server and what kind of response is coming back from the server. So in that way you will have a good idea, like, okay, to create a profile, maybe I have to give this many parameters and request post request. Then profile has been created, and then you want to check the details of the profile. And when you refresh the browser, go again to your browser inspect tool and see, okay, get request, it is returning this, and it is matching with whatever you are seeing in your front end, basically.
Right.
There are two ways you can explore the APIs.
Nice. I think you've covered both ways. And so where would API testing fit in the famous testing pyramid, according to you?
Okay, it's a good question. So testing pyramid is not just for API testing. I think that is the guiding force for any kind of testing strategy. And for API testing, basically, suppose you are just testing your backend platform, then pyramid is must to have. So it has a different layers, as you know, like starting from the bottom of the pyramid, unit tests. So you can write all your unit level tests. Those will be, dev facing tests, basically, right? So those will be part of your code repository, and those tests will be running in the CI. So obviously we actually expect faster response. So most of the cases you will be verifying only the business logic or services logic there, but with the mocks. You will not actually send a request via the wire to another destination, but you will use mocks. Then after that, you will be having the integration. So that is important because you will be integrating your API with different things, right? So you might be integrating with a third-party application. You might be integrating with a different API, which might be part of your code only, but it is a different microservices. You might be integrating with your database. You might be integrating with your messaging system like queues, and also as part of your requirement, you will be doing the integration test. Again, integration test also mostly we do using mocking tools. Whenever it is possible, we do use wire mock kind of tools, and we verify the integration logics basically. The third important test is like your contract test, which is specific for APIs, because APIs are cannot exist without this consumer and producer relationship, right? So API can be either a consumer or a producer, and depending on the responsibility an API is doing, probably we define our contract test in a similar way. Again, we can use tools like Pact if all the APIs belongs to the same code base. But if you are actually integrating with a third party, then contract testing is a bit tricky, because if the third party is not using the same technology stack what you are using, then probably you have to go ahead with some other tools like Postman or something different, other contract testing tool. But otherwise, contract testing within your code base, tools like Pact can be helpful. And after that, these three kind of tests, right? Unit test, integration test, and contract test. These are like a dev facing test, as I told before. So after that, you will be doing your system integration test, right? So system integration test basically, we will not use mocks. So we'll be calling, your other APIs or dependencies, the real ones. So those are like part of your pyramid, but those tests will be very minimum test, not like, the all error conditions and scenarios. Those will be, you might have already verified in your unit and integration testing, but all your happy path scenarios, you can test in your system integration test. Then finally, on the top of the small part of our pyramid, which is like a for end-to-end integration test, we can call, where the end-to-end business flow will verify. Depends if you have a front end, then we can use like tools like Selenium. But suppose it is just a front end is not there, you are testing only your platform, then API chaining with business flows you can use. Again, tools like REST Assured or Postman or Karate DSL you can use in the top layer with happy path scenarios. So this pyramid helps us actually to place the test in the right kind of layers, as well as minimize duplication of the test.
I think so. The next question would be on similar lines, that what would be your testing strategy to test APIs? I know you've given away some tips in the previous two questions, but anything further to add in the testing strategy for APIs?
Actually, yes. There are a few other things. Like generally what I do, like I follow the testing pyramid very strictly, so that all the tests are in the right place. And then I use actually quality characteristics to map, if anything is missed. For example, our typical quality attributes like functionality, then performance, then security, then maybe your maintenance and reliability, right? So those things, portability, right? So those quality characteristics I try to map with the pyramid if anything missed. Now, mostly in the pyramid will be, cover the functional aspect, but there are two more important aspects like security and performance that will come from the quality characteristics. And then it will also help you to dig deeper into each areas. For example, like functionality, right? So under functionality, you might be different criteria you can verify. So how you can actually get more coverage on your functional side. Then maybe usability, right? So if you see usability is morely, we talk about usability when we test the front end, but in the APIs also usability is very important. Right? If your user documentation is not proper, then how the consumers will consume those APIs, right? So we have to consider those points also, like usability, then reliability. Reliability, different tools are there to check how reliable your API is. So quality attribute combined with your testing pyramid, I think give a solid testing strategy for APIs.
Okay, and you just spoke of testing the APIs for reliability. I mean, when you say that the APIs are reliable, I mean, how do we test that they don't cheat on us?
Yeah, they can cheat on us. That is possible, especially in the microservices world, right? Because all the microservices are independently deployable, right? You deploy all different microservices in variety of containers, then, what will happen if one container is down? How you will make out, right? Or if any problem is coming from a third party, right? So how you will actually make out like, okay, problem is coming from the third party or problem is in the DB, right? So, so all those things, all those issues you can actually, target using reliability testing. So mostly, reliability is now part of the reliability engineering team, software reliability engineering team, SRE team. So what they do basically for them, it is monitoring is very important. Right. So as you know, right, in microservices world, right. So you need to continuously monitor your APIs, right. So adding right kind of logs. As a tester, we also need to see like what kind of logs actually developer is adding. if anything goes wrong, can we identify those problems? Right, what kind of traces we are generating, right, for a business flow, right, what kind of traces actually we are generating from our application. Now, like, it is simple because we have tools like Datadog, Splunk, right, where we can actually see all those things. Like, we can, all that code, they will add correlation IDs, users take the correlation ID, go to your logging system and see what went wrong. Right? So logging, monitoring is very important, specifically in microservices, so that we can actually deliver a reliable product.
Nice, nice. I think that was quite a tangible tip there. Checking reliability via monitoring. So, as we speak of monitoring, my next question would be, how do we test the performance of the APIs?
Okay.
And
Again,
can you
performance.
elaborate? Yeah, could you
Sure.
elaborate with a relatable example? Yeah.
Sure. See, when we say the performance of any particular application, end-to-end performance, right? So there will be different parts of it, right? So performance can come from the front end. Performance can be part of the back-end APIs. Performance maybe due to your DB connections or connectivity. Performance can be due to the third-party services you are calling in, right? So when we do performance testing, we should be sure like what performance we are measuring. In case of APIs, again there will be multiple stages here because microservices itself will add on latency. Because see, microservices are running in different containers, so you have to use internet to connect to and communicate, so latency will be always there. But on top of that, is there any other problem? Right, because even DB connection also, it will be via internet, because DB will be also running in some container, so you have to maybe in some cloud it will be residing, you have to connect to the DB, right? Then even third parties, right? So your performance strategy should actually focus on those parts, like, so that you can identify the right bottleneck from where the performance lag is actually happening. Is it because of our API code, basically, right? So if we know like performance problem is coming from the API backend code, so we can optimize the code. Maybe performance is due to the not due to the code, but maybe due to the query we have written, right? SQL query. So we can optimize the SQL query, right? So then maybe performance is not in our control, it is coming from third party. So if we are sure like okay, performance bottleneck is due to third party, we can inform them like this is the spike we are seeing in our performance test. So to define your performance, goals or performance requirements, identify your performance, timelines, like okay, what should be the response time, what should be the throughput for a particular request. So if you identify that, you can very well write your test scenarios for doing the actual performance testing. Because I have seen many times in my experience, like most of the cases performance are due to all these external factors, not just because of the code.
Okay, that was quite insightful. The various parameters that you just mentioned to test the performance against, and what could be the causes. Usually, when people think of performance, all they think of is the performance that could be due to the server load or something of that sort.
Yeah, because nowadays, see, we use sophisticated load balancing techniques, right? So API gateway is there, which will take care of all the load balancing stuff. So it might not be just because of server we are getting performance bottleneck. It can be anything.
So you also spoke of security. So what would be the repercussions of not testing the APIs for security? And are you aware of any, real incidents that have happened because of this?
Yeah, security is very much important. if you are testing a banking application, for example, you can see all these fraud things are happening, right? Because our connections are not secure. Recently, Log4j security issue has come, right? So those kind of scenarios, those kind of incidents keeps popping up. And since API are the backbone of our application, so it's our responsibility to make it secure. Right. So first thing will be like maybe we say, okay, we have authentication or authorization in place, right? Is that enough? I would say no. That is just a gate. But you may have vulnerability inside your code also. Suppose you are using, API tokens and all, right? So we use API tokens, keys and all, and by mistake we committed that keys in GitHub, right? That can be leaked, right? So that is one way. Secret we have to protect. And nowadays we are using Vault, so we want to make sure secrets are protected. Even before that, there are tools like which will help us to prevent committing those secrets into our repository. Then for security testing, first step is like your code basically. So we use static code scanners to check if any vulnerability is there present in our code to make sure our code is good enough. Then next thing is, since we will be deploying our application in containers, so our Docker image security has to be there, right? So your Docker image should be signed image, right? When we take enterprise license of Dockers, they always give a signed image of the Dockers. So that we should prefer to use. Then next level it will be like our orchestration level, the Kubernetes and all, which will monitor all the containers security at that level. The final thing is like the cloud security. Yes, cloud providers also guarantee certain level of security. We should leverage that. But again, monitoring tools, those are very helpful. Because we should know, who is accessing our APIs. I mean, recently one funny incident happened. I was just, trying some APIs in a non-prod environment from the Postman, and the volume was a little bit higher. Then suddenly I came to know, I am blocked. And I was thinking why I am blocked, and I checked with some other people. They said, no, we are not blocked. I think only your IP is blocked. Then I, contact the monitoring team, and they said, yeah, I mean, we saw, more requests coming from your IP address. Since I missed to pass one specific, user agent parameter. So to keep it safe, although it is a non-prod environment, still, they blocked my IP. So that kind of monitoring should be in place. I feel good about it. Like at least they are monitoring even non-prod environment. So production environment, it is must. I mean, that is really helpful.
Yeah, I mean, very well explained. Thank you. And so does the testing or the testing strategy differ between different protocols like REST, SOAP, and GraphQL?
Okay, this REST, SOAP, or GraphQL are the different types or different designs of API, right? So the way we design API may vary depending on our requirement or functionality we're looking for. REST, we cannot control, right, what kind of response we are getting, right? So whatever server is actually returning, we have to accept that. But GraphQL is a little bit flexible in that manner. We can actually tell GraphQL server that we want only 2 parameters out of those 100 parameters, and accordingly it returns. But in terms of testing strategy, I would see not much difference, because end of the day we test the functionality or maybe the performance, right? So the way we use the designs might be different. For REST, maybe we use one tool, maybe GraphQL we might be using different tool. For SOAP, maybe we will use SOAP UI, or if it is an event-driven architecture, then probably we'll go with Kafka clients, right? So We should always remember that our focus should be on the functional flow validation, not verifying Kafka, because we are not going to test Kafka. We'll be testing, whether our messages are passed into Kafka and the consumer is receiving the messages. There should not be any message loss, right? But Kafka itself, right, when you deploy the Kafka, so the deployment team will take care of all the necessary things which we need, basically. So our focus should be always in the functional or business validation. That's what I feel.
Okay, and you spoke of tools also briefly. Which is your preferred testing tool for APIs?
Always Postman. So I always start, irrespective of any framework I use, but starting point is always Postman, because that little GUI can give me everything I want to explore in API. So even I'm seeing like all the developers also are actually using Postmans always. So that is the best friend. But other than Postman, there are a lot of tools like, Karate DSL is one, especially for the microservices testing. It helps, and even it is a low code tool. So that is very powerful tool. Then we have Rest Assured, which all the Java developers love. And then other programming language also, we have similar kind of frameworks. So there are a lot of tools, but yeah, I feel Postman is a little more close to heart, but I'm okay with using any kind of tools.
Okay, and Dimpy, since you've spent like 18 plus years in the industry, what would be those tips that you would give to our software community or software testers that they shouldn't do? Like, what should testers not do would be my question.
Okay, so even I have done a lot of mistake in my past. Not asking the right kind of questions, right? So sometimes we feel like, okay, what that person will say if my question is not valid, right? So always start with asking right kind of questions. Don't keep anything in an assumption state, right? So don't assume and test. Know and test. You can explore. You will find defects, but don't assume that this should happen only this way, right? So when you ask more questions, you will get more ideas, basically. So your thought process also will build. So start with asking right questions, take notes, and explore technology. For example, now you are testing a microservices, right? So you should know actually what microservices architecture is. Although you may not going to write a code as a tester, but understanding of the technology is always helpful, especially when you use testing pyramids and all, right? So how you can actually make sure what kind of test is a right fit for a particular layer, right? So if you know, okay, these things can be covered in unit test, then don't spend a lot of time writing end-to-end test, basically.
Right.
So collaboration is key. Collaborate with your team and ask questions, take their help, and educate them about testing. Basically, if you see, most of the time we see people are not aware of testing, like what are the different tools, techniques, test design techniques are used, right? So how can we get more testing coverage? How can we write better tests, right? So that if you are involving the team along with you, you don't need to do all the heavyweight testing alone, right? After the application is ready, all the testing work will be loaded on you in case you don't educate your team. So take your time, understand everything, and then help your team to understand what are the scenarios, how can you improve the process, basically, right? Then debugging. Those are the key skills actually testers should learn. Don't shy away from asking, to somebody who is working on the debugging part, right? So maybe monitoring part, right? So don't think like, okay, it may not help me if I understand the debugging tools or logging. So learn those things so that you can use those, basically.
And I have to say they are brilliant suggestions, and this is what makes a beautiful tester, a strong tester. And this only comes from experience, though, Dimpy. And
Yeah,
thank you for sharing it with our
yes.
audience.
Yeah, I have made those mistakes before, not paying attention to monitorings or loggings and all. But now I know.
Okay. So Dimpy says, do not assume. Please ask more questions. Collaborate with your team members. Learn about the underlying technology. Yeah. So, with that, we've come to the end of this episode of QA Q&A. And I'd like to thank everybody for joining us. We hope you enjoyed our discussion on API testing. And we are grateful to Dimpy for sharing their expertise and insights with us. And we hope that you were able to take away some valuable information from today's episode. As always, we would appreciate your support and feedback. And if you have any questions, please don't forget to comment below this video, and we'll try best to answer everyone. And for more QA content, don't forget to follow us on LinkedIn, Twitter, and Instagram. We look forward to hearing from you on the next episode and bringing you more engaging content on quality and testing. Until then, it's me signing off. Bye bye.